Well, first off, thanks to Theo for an inspirational start. And if you haven't read a remarkably fabulous and short piece in the magazine Philanthropy by Bill himself, I commend it to you because it outlines the 7 mistakes philanthropists have made in supporting climate advocates to date. And it does so in a very coherent and succinct, and from my perspective, entirely accurate perspective that is both respectful of climate change and its urgency, but also for the very first time, although we're starting to see a couple of these pop up, acknowledging just the unbelievably ineffective, expensive, and racist climate dogma that has brought us to this period. I am a Berkeley liberal. That puts me on the far right of the Berkeley political spectrum. It is disorienting. But when the California Air Resources Board, comprised entirely of Democratic appointees, unanimously approves a set of climate change measures in its blueprint of state policy called the Scoping Plan, which says at the bottom of page 126 that collectively the measures that we've chosen will cost households earning $100,000 or less $5.3 billion a year. But wealthier households will actually save money through some magic math that is still unclear. And then in the very next paragraph says, and it's true that cost hit of $5.3 billion a year in the state with the nation's highest poverty rate, highest housing costs, highest homeless population, that $5.3 million climate hit based on the policy choices made by our elected and appointed leaders will disproportionately affect demographics being whatnot, Black and brown communities. Really. Imagine if the education board decided to pick the curriculum that would assure Black and brown folks wouldn't read. Oh, they kind of did that when they abandoned phonics. The lack of self-awareness, the lack of any lens that is respectful of people like my family, grew up in the trades, Pittsburgh, California, U.S. Steel, daughter and granddaughter of steel workers, California style, wiped out, of course, with globalization. But these are not people that those who write or advocate in the climate movement know or respect. We rejoice whenever anyone leaves California, because based on that fraudulent climate metric that everyone in this room has sort of nodded to for the last 20 years, we draw a geographic boundary around a state or a city and say, you get inside that boundary for anthropogenic causes only to net zero or 80% below. And you get to count people who leave and move to Texas, our host, where per capita and per GDP emissions of greenhouse gases are far higher. But that's okay. California gets to count toward its climate leadership goals the loss of 600,000 people because they're not spewing those GHGs that come with waking up, turning on the faucet or a light, or jumping in a car, which 97% of us do in California, to work. Our ignorance, our absolute hostility toward people in this climate movement is shocking. And frankly, in a normal world, which we're not in, should be illegal under civil rights laws. Instead, we have, and I'll close with this, innovative climate policies, like the idea that vehicle miles traveled for a 30-year period are impacts. Even if they're in an electric vehicle, the act of driving is an impact. And so we're going to take that VMT impact, we're going to calculate 30 years worth of occupant vehicle use, along with visitor and vendor visits to that home, and we're going to roll mitigation of VMT impacts in the name of climate into the cost of a new home. Goody. Now it's a more expensive home. How much more expensive? $40,000 per apartment. That's how much more expensive. Roll it into the price, but there's more. You get to roll it into the mortgage, pay even longer. Get to roll it into the property tax base, pay even higher property taxes, and best of all, my generation won't pay it. We got ours. It is a brutal attack on the young. It is countered to some extent by an extremely elitist urbanist agenda called abundance, but at least it's there. Blue states that can't build aren't serving any of us, including liberals, let alone progressives. So it is time for a reckoning. Bill called the question with philanthropists. I hope the folks in this room will recognize the seriousness of the question, will recognize what happens when I have a carbon sequestration project attached to an existing natural gas plant that is sued by Earth Justice, which doesn't want CSS because it enables fossil fuel for a plant that's already operating. We have oil production fields in Kern County employ overwhelmingly Black and brown non-high school or non-college graduates with good jobs that are irreplaceable, with unquestioned science saying it's better to produce locally and refine locally than hope for the best from a ship coming from somewhere. But it's more important to, quote, keep it in the ground. These are Pyrrhic victories by Hollywood, by dogmatists, and by illiberal domination of racist climate policies. Basta, enough. That's the Sicilian side.
There you go, there you go. Well, I really wish you had taken the gloves off. Tell it the way it is, actually.
Wow,
So,
yeah.
One of the lessons I learned early on in my activist career was that it takes so much courage, I think, to say the truth about the limits of your own movement. I'm not coughing. There we go. It can take so much courage to simply say the truth about your own movement and your own people, but that's what you need to do if you want to be a true advocate, a true activist, to actually accomplish things. You can't just bend the numbers so that your intentions look like they're having a positive reality, and you can't just try to say that we are for the environment, for justice, for, you have to actually do it. And it's not hard for us to do it. And the people in this room can cause this to happen. And I mean that in a literal sense. I know the people, I'm looking around at people that we can connect together to do this. And we can get it done. Hillary, tell us your perspective of these crazy times. You've been doing mergers and acquisitions. You're seeing, mergers and acquisitions happening on the national basis now. What's your perspective on the future of our energy and where we can go from here?
Sure. So, to put it in perspective, so I do mergers and acquisitions, but I also spend a lot of my time capital raising. So, working in capital markets, both debt and equity for companies all over the energy spectrum. I've been doing it for 25 years. And so started in traditional oil and gas and have moved into the broader energy industry as it has naturally broadened, because it is the oil and gas companies that have moved into new energy, funding CCUS funding the large projects because they have the free cash flow in the balance sheet to do it. So it's been an interesting journey. So it's so funny because people say, oh, it's crazy times. And I'm like, it's been crazy times for 25 years. Like this is an industry that's always crazy times. That's why I love it. It's always innovative. I'm a fourth generation Houstonian married to a fifth generation Texan from the Panhandle, literally, living on a ranch, with oil and gas royalties and all the stuff. So I think first time I went and met my husband's family, literally in the cafe where we went to have a burger, these guys walked in their white T-shirts with their giant belt buckles, literally covered in oil. Like, I don't know where I was, and I'm from Texas, but I was from Houston, so it's just a different world up there. So this is old school. And then as the years go by, I saw the oil and gas industry with the shale revolution. Obviously, we moved in, it was first gas, and then it was oil, and then, and we had the midstream boom on the capital raising side. We had wild multiples, and then, we moved into more infrastructure projects. And then, eventually we moved to net oil exporter, and, we moved into LNG projects, and then we moved into new energy. So it's always a journey in the energy industry. And so my approach has always been, we need all of it, we need, and, IEA projects, at least 60% of the world energy sources in 2030, even on a very aggressive forecast for new energy sources, will still come from fossil fuels. So it's not an either or scenario. And energy transition, I think, is a really lazy term. It's energy expansion, or it's energy evolution, or whatever terminology you want to use, but it is certainly not energy transition. You'll never go all the way to, I don't know about never, because
I don't think there's ever been an energy source on the planet that was and now isn't.
Correct, right,
Anything
absolutely.
that was once used for energy and now is just not anywhere?
Right, and if we ever stop innovating, then, we'll lose, obviously, and I just don't think humans can ever stop innovating, too. So we'll need different sources of energy in different places around the world. The discussion at lunch around the grid, that proves that we need different types of energy sources, then we need to figure out how to transmit it, and on and on. So anyway, so it's there's just a massive tension between this, conservation versus sources of energy versus getting the sources of energy to the people that need it. But in the end, it's just a matter of everybody coming together to just get the smartest people in the room with the best technology to just find the path forward. So it can't be political, it can't be, but if you're going to be practical, I say just be practical about it. But if you're going to be practical about it, you have to admit that it is political, is the problem.
It's all of those.
So, right, it's all of those things.
Yeah.
So, we have to find the way to navigate it.
Yeah, the idea of a transition is an old industrial way of thinking, where you're going from one thing to the other thing. And that's not the way ecosystems work. They go from singularity to diversity. And we're seeing this diversification of energy sources and ways of using energy. We're at the same time, while we have a multitude of new forms of energy that are emerging, we also have technologies that radically reduce the amount of energy we need to use for everything that we do. And then we have other technologies that are radically increasing our appetite for this extremely efficient use of energy. And so it's a whole complex ecosystem of energy sources and uses within which we have many solutions. That's the nice thing about diversity, is that no matter what your conditions, when you have diversity, you have a variety of paths you can follow, not just one.
But one thing I worry about is I don't think that yet we're very good at finding the synergies between, the connections between those sources. I don't think we're very efficient at connecting those to find the efficiencies between them. These are capital intensive projects.
Yeah.
These are very expensive These are very expensive sources of energy, whether it's at the innovative stage or at the capital development stage. And so what we've seen, like for example, in 2025, obviously the political winds have shifted. We've seen the government incentives shift. Obviously there's 5 main categories of major sources of capital for the energy projects, whether you're talking on the traditional fossil fuel side or you're talking the new energy side. And we've seen 2 of those flip with the change in administration, and then that's driven a flip in a couple of the private sources of capital. Okay, so that means we have to adjust and find the connections if we're going to continue to fund new energies as the traditional sources see more inflow of capital. That means there's going to be more free cash flow, more availability of cash from the traditional sources of energy that could then fund the new energy. So how can we connect those? So it can't be that they're in tension with each other. They need to work together, and we're just not good at doing that.
We haven't found a way to do that yet.
Yeah.
I just wanted to, first of all, it's easy to follow. Just a couple of quick things. I worked in the energy industry about 30 years, and over the last 5 years, I've been spending a lot of time with clients, consultants, so on. A few things. First of all, this point about uncertainty. So what I hear from the companies consistently, and this is this year at the Zero Week Energy Conference and so on, is they don't like this uncertainty and this swing from one way back to another. So this work on finding the sensible center is really important. Also, while they welcome regulatory simplification and they want permitting reform badly so we can build and they can invest, they don't want all the regulations to be repealed either. I heard a number of companies say there's something called the Greenhouse Gas Reporting Program. Well, the companies use that to verify what the emissions are across they don't really want that to go away. So I think the companies are making those views felt. And later on, I'm going to talk about the energy dominance in America First case for continuing in a smart way to pay attention to emissions. And then the last thing I want to say, coming back to where I started with the Pope, because I like to be a perennial optimist. You don't hear the companies saying climate change isn't real at these conferences and so on, right? They know it needs to be addressed, and they are hearing it from their investors, from their customers, from the markets where they want to sell, for example, Europe and so on. And they have to invest, just like your clients, both your clients, for the long term. So they're not saying, oh, we're going to just stop worrying about this. They are still concerned about it, and they're speaking about it. And so optimistically, it is not going to happen as fast as any of us want. And I think the realism about what the transition is and having those conversations is important. But I think there's more commonality, as in most things, than we really think.
Yes. Thank you, the 3 of you. We really appreciate your send-off to us in this initial conversation. And let's have a round of applause for Hillary, Jennifer, and Bob. And next up, it used to be that fossil fuels were the dominant source of power. Energy power, political power, industrial power.
No.
But we all know that knowledge is also power, and we're seeing an economy that's shifting more from the material to the immaterial, from hardcore resources to embedded knowledge in our products and services. Knowledge is power, and data is a path to that knowledge and that power. One of the richest sources of data on climate is held by MIT. And Professor John Sterman and Bethany Patten of the MIT Climate Center have, with the help of Michael Sonnenfeld and others, taken that enormous storehouse of data and turned it into a database that anyone can access easily on their computer to test their knowledge and deepen our knowledge about how to move beyond our dependence on carbon as a pollutant associated with our growth. So I want to invite Dr. Sterman and Bethany Patten to come on up and walk you through a process called En-ROADS. And I'm just going to leave it to you, John, to describe what this is. And we're all going to engage in a process to try to solve the climate problem, throwing out ideas that John will document for us. John?
All right, well, so thank you, Bill, and thank you to the three panelists and, of course, the fantastic poems. I'm very pleased to be here. And what we're going to do is we're going to have you all solve the climate crisis. You're not going to get a lecture from me. And the reason we're doing this is, well, research shows that showing people research doesn't work. The more an expert shows you a million PowerPoint slides, the more you're on your phone and your eyes glaze over. So what we have done in the work that we've been leading at MIT through the Climate Policy Center, which is nonpartisan, non-profit, non-commercial, data-based, independent, is we have developed an interactive simulator of the global climate, and it looks like this. Now, that's a slide. In just a minute, you're going to have a chance to tell me how you'd like to address the climate crisis. But first, just a little background. First, I want to introduce my colleague, Bethany Patten, who's the executive director of the MIT Climate Policy Center. We have a lot of work going on in that domain, but we're going to focus today on the En-ROADS simulator, which we have developed in partnership with Climate Interactive, a nonprofit, nonpartisan think and do tank founded by, well, one of my former students, Drew Jones, and has a large team without which we could not do this work. So the simulator I'm going to share with you has been used all over the world. 440,000 people have participated in events like this or role plays of the global climate negotiations in 178 countries, and more than 18,000 of them are senior leaders in government, in civil society, and investing and in business all around the world. For example, here, and I won't go through this, but my team and I, we've been briefing senior members of our government and other governments, 200 members of the Senate and Congress, dozen governors, members of the administrations, et cetera, and many of the other countries. So that's enough PowerPoint. Let's get out of that and let's do it. So I'm going to have to explain this real briefly, and I encourage you, in fact, I require you to interrupt me, ask me questions, challenge me, disagree. It's really important. So what have we got here? This is the simulator. It's available in 21 languages. Excuse me. And you can try any of them out, but we'll go English today. It's fully documented. Every equation is there for you to look at. And remember, all models are imperfect, including this one. So part of your role here today is not just to build a scenario that can get us to a safer climate, but tell us what you think is missing, needs improvement, or just plain wrong in this simulator, because all models are imperfect and we're constantly improving it and issuing new versions. All right, so what have we got here? Well, take a look at this graph here. From the year 2000 to 2100, you have global primary energy use, the total amount of energy that humanity is using. And you can see where it's coming from. So we just heard about the need for, or the existence of, all of these different sources. Well, down here in brown at the bottom, that's coal. Here in red is petroleum. Then we have fossil gas, natural gas in blue. In the model, we've got wind and solar and hydro and geothermal and other renewables. They're all basically producing essentially carbon-free energy, so they're added together in that green wedge of renewables. 3 ways to make bioenergy in the model: from wood, from wastes, from crops and crop residues, and then nuclear power on top. So what do you see here? What you see is growth in total energy demand. Well, why is that happening? That's happening because population is growing. So we're using the UN's most recent projection, which you can see here by region, and they're telling us 2 billion more people will be added to the 8.2 billion we already have by the year 2100. Now, the way the model works is all of these assumptions are uncertain. You just heard about uncertainty. So you don't have to accept my word for it. You can try your own ideas. So maybe global population will be lower or higher. And if I change it, you can see the entire model, which is a model of the global economy, energy system, and climate, and how they all interact and feed back on one another. It instantly shows you what the likely result would be. I'm going to leave population at the UN's base case. And similarly, the growth in energy demand depends also on future economic growth, which you can see here. This is real gross world product per capita by region. Just like population, you can change all of these assumptions too. We also have, I'm from MIT, we love technology. There's technological progress and innovation baked in here. So if you look, for example, here, you can see how much energy you need to produce a real dollar of economic output has been going down, technological progress, and it's projected in our story here to continue to go down at about the same fractional rate. So what's the result? The result is the economy grows, there's more people on the planet, and that means more energy demand, even as efficiency improves. A consequence of that, you can see that most of the growth is taken up by renewables here. But that leaves you, in our baseline case, an economy that is strongly dependent on fossil fuels going forward to 2100, coal, oil, and gas. What does that do? It means you get moderate growth in greenhouse gas emissions that are warming the planet. The big gray band there, that's the biggest contributor to climate change. That is the carbon dioxide that is generated when we use the coal, oil, and gas right here. The second biggest contributor to global warming is here. That's methane. Methane is the main constituent in natural gas, but it's also emitted into the atmosphere by the energy system from leakage, from wells, from processing, from industry, and from agriculture, and it's a very powerful greenhouse gas, second biggest contributor. The third biggest contributor down here, that's the carbon dioxide coming from land deforestation, land degradation. And then, excuse me, anybody have some water? That would be helpful. Sorry. And then that purple band, that is nitrous oxide, N2O, very powerful, very long-lived gas, and it is primarily generated by excessive use of synthetic fertilizers and some industrial applications. And then that yellow band, those are the fluorinated gases, CFCs, PFCs, sulfur hexafluoride. Oh, thank you so much, Jennifer. Really appreciate that. Thank you. And these are very powerful and long-lived greenhouse gases. So what you see is energy use grows, greenhouse gases grow, not quite as much because there's growing renewables. And the consequence of that is by the year 2100, we're looking at 3.3 degrees C or 6 Fahrenheit above pre-industrial levels. And you can see what's happening here. Today, we're just about at 1.5 degrees or 2.7 Fahrenheit. That's the aspirational target from Paris. And I was there using our tools to try to help out. But at that time, a lot of people thought, well, we're going to be at 1.5 before too long. Well, that's now. That's where we are right now. In this scenario, with continued dependence on fossil energy, we breach the 2 degree, 3.6 Fahrenheit upper maximum limit from Paris by mid-century, and it just keeps going up, 3.3, and it would keep going. So what would that mean? So 3.3 is just a number, but what would that mean? Well, it would mean nothing short of catastrophe for humanity. Now, I know that's a strong word, and I know I'm putting my reputation as a scientist on the line when I use it. Let me tell you what the IPCC says, the Intergovernmental Panel on Climate Change. Quote, we get up to this kind of temperature, severe and irreversible consequences with limited ability to adapt. Now that's science speak. Let me give you an analogy. Suppose you go to your doctor and you say, Doc, I really don't feel good. For the last few years, I've been hot all the time. I have these unexplained fevers. I've got pain. My brain is foggy. Something is really wrong. Can you help me out? And your doctor says, we're going to run all the tests. Don't worry. Tests come back and your doctor tells you, you better sit down because what you've got is a condition that's leading to severe and irreversible consequences, and there's almost nothing we can do for you. Most people would consider that a catastrophic diagnosis. So why? Well, we keep track in a model of as many of the impacts of climate change for which there's a solid scientific basis. So for example, air pollution emitted by burning fossil fuels and other sources. This is PM 2.5. World Health Organization tells us this kills 8 million people prematurely around the world every year. The official WHO death toll from COVID is less than that, 7.7 million. This is a COVID worth of death every year from the pollution that we're generating. What else? I mean, there are more here that I'm going to spend time on. But for example, crop yields are likely to fall as the result of continued global warming by double-digit amounts for corn and wheat, 8% for rice and soy. This is in a world where we're expecting to have to feed 2 billion more people. And why does this happen? It happens because of drought. It happens because of extreme weather. It happens because of flooding and other issues that lower the crop yield. What else is going on? Well, what about sea level rise? So here's the Gulf Coast, and this is just 2050. This isn't even 2100. All the land that would be inundated permanently by the warming. Now, of course, this is over-optimistic because we do get hurricanes down in the Gulf. And, well, what if we had a storm surge of about 3 meters, which is pretty small. We had bigger storm surges for Hurricane Milton that we just had, Helene, going way back, Katrina. Take a look at that. That's catastrophe. And you're welcome to use this. It's free. Take a look at any part of the world you're interested in and take a look at your favorite coastal region. This shows you how much it's likely to warm up anywhere you want to look in the world. So 2020, so pretty much now, average 1.3 C globally. Right here where we are today, 1.5. Where are we going? So the yellow colors, about 1 degree warmer. As you get up into these hotter colors, hotter and hotter. So this is today. Let's go to 2100. It'll take a second. 3.8 C. That is about 7 degrees Fahrenheit hotter than it is here. That's average year round. Think about what it's going to be like here in the summer. You can look anywhere you want. This is not great. What else is happening? This shows all of North America. You can look at the whole world, but wildfire risk. So again, the colors mean already the warming we've got, where it's yellow, 7 to 13 days more of severe wildfire danger every year. Well, let's take a look. And not much is happening up in Canada here in Florida, but let's take a look. This is today. Let's go to 2100. This is going to make what just happened in Los Angeles look like your backyard barbecue. There's a lot more harms from climate change that we could look at, and I welcome you to do that, but this is just a little taste. The real challenge is, what are we going to do about it? So here's our baseline case. Now down here, you've got all of these policy actions. You could, for example, work on the energy supply over here, disincentivize coal or oil or gas. You could promote or disincentivize bioenergy. You could promote renewables. You could also disincentivize them. Or nuclear. This thing here called New Zero Carbon, that simulates what would happen if we had a major breakthrough that might allow, for example, fusion power to be commercially possible. You could put a price on carbon. Bob talked about all the major oil companies in Paris, and they have not gone back on their word yet, have supported carbon pricing. You can try it out. Here we can look at improving energy efficiency in transportation, in buildings, in industry. You can electrify end uses. Over here, nature-based solutions, afforestation, planting trees, carbon smart agriculture. You could reduce the emissions from agriculture. You can reduce deforestation. You could try technological carbon dioxide removal. We also have carbon capture and sequestration in the model. So now, what do you want to try? I never tell people what to try. So I'm going to start with, I'm from the business school at MIT. That means we call on our students. We cold call. So I'm going to do that. How about way in the back, sir? What's your idea?
Carbon capture technology.
Carbon capture. All right, great. Why don't we try it? So there's a lot of natural gas here. There's also coal. Now, most of the oil is burned for transportation or petrochemicals, so it's difficult to put a little carbon capture unit on your tailpipe. So it's mostly going to be power plants and big industrial facilities. Why don't we take a look at carbon capture on coal? So we can do that right here, carbon capture and storage for gas. Now, under the Inflation Reduction Act, the subsidy available in the United States for CCS for coal is $85 per ton of carbon. So why don't we try that? Now, we're at 3.3 degrees of warming. Let's try $85 and see what happens. Okay, we got CCS. Let's take a look and see if we got it. Yep, there it is. Not too much. Now, this is a global model. So we got some in the US, but we didn't get a lot globally, and it didn't make any difference for climate change. Well, how about a bigger subsidy? How about we, double it? Still 3.3. Get a lot of CCS now. Here's the industrial side. Here's the electric generation side. It's not making that much difference. How come? It is not profitable today, right? We do have a learning curve, so it does get cheaper if you're able to start deploying it, scale economies learning, but that's not happening very much. Even at $175, in many parts of the world, it's still too gosh darn expensive.
What if I can remove that brown line, make whoever helps me billions of dollars?
Okay, so let's get some other voices in the conversation. But here's what one of the surprising things that we find is CCS will happen if we can subsidize it sufficiently and try to kickstart scale economies and learning. But it takes a long time to deploy. It's not going to be profitable in many parts of the world, and it doesn't make that much difference on the climate. So how about another idea? Who's got one? Sir, way in the back. Okay, great. So let's look at some nature-based solutions. And you said reforestation? Yes. Great. So let's plant some trees. All right. So down here, we can really promote afforestation. That's planting new trees where it's been forest-free for a long time, and reforestation in where it's been recently deforested. So estimates of how much land is available differ a lot, and we've got a very optimistic total here, but let's really crank it up. Let's assume all of that land could be planted with trees. It probably can't be because it might compromise food production, and there's other issues there. But now take a look. This is the amount of carbon dioxide, this graph, the amount of carbon dioxide being removed by those trees every year. And it's a lot. It's 5 billion tons per year. That's about a little shy of 10% of global emissions today. It's about 8% of global emissions today. That's a lot. What difference did it make to the climate? 1/10 of a degree. Now, every 10th matters. But why doesn't it do more? Yes, ma'am. So, right, take a look. It did shrink the green band here. That's good. But it didn't do anything for the biggest contributor to climate change, which is the CO2 from burning your fossil fuels. Didn't do anything there. So look, every 10th matters. Let's keep it. Got some other ideas? Yes, sir, right there.
How about more renewable and nuclear?
Okay. Well, that's two. Let's try. Which do you want to do first? Nuclear? All right. So right now, let's take a look and see how much nuclear we're getting. So it stays pretty steady. Why is that? Nuclear is very, very expensive. This is the marginal cost of making electricity in all the different ways we can do it. So brown is coal, green is your renewables, which are now the cheapest way to make electricity. Wind and solar cheaper than anything else. Nuclear is way up here. It's pretty expensive. So what if, as part of a climate strategy, we promoted, incentivized, subsidized nuclear. And what I'm going to do is I'm going to subsidize the heck out of it. Is that okay? All right, 3.2, another tenth of a degree. What happened to our energy mix? Well, here it is. A tenth of a degree. It didn't make a huge amount of difference. How come? Well, the first question is, did we in fact get more nuclear? And yes, we sure did. We got a whole lot more nuclear now. But why doesn't it make more difference to the climate? It's not producing carbon. It takes carbon to make them, and we account for that, but that's not an enormous issue. It's not producing carbon. Why doesn't it make more difference to the climate? Well, it's displacing some of the other fuels. Take a look here, right? So here's coal, and so oil we're not using for electricity, but coal and gas and renewables and bio. And when you bring in the nuclear, what happens? There's less coal, there's less gas, there's also fewer renewables, right? You go to an electric utility and you say, we now have a subsidy package that makes nuclear very attractive for you. Great, I'm going to build more nuclear plants. I'm also not going to build as many utility scale solar plants and offshore wind farms. So you're cannibalizing to some degree the other zero carbon energy sources. The other thing going on here, of course, is take a look at the timing. When does nuclear really, so the subsidy starts today. You can change that, but it starts today. When does nuclear really get big? It takes a long time. It takes a long time to conceive, permit, design, and build and commission nuclear plants. And in the meantime, you're still burning all that fossil fuel. Okay, let's keep going. 3.1, we got a long way to go to get to well below 2. C. Go ahead, sir.
I was interested because Bill talked a lot about ecosystem, and thanks for that. A few times I've heard that from Denmark, so it's a global issue. But in Denmark, we looked at displacing industrial and transportation use of fossil fuels
Okay.
by
How?
reorganizing the ecosystem.
So,
So direct connections to renewables, accumulating industrial and transportation fuel growth by directly connecting traditionality and renewable energy.
great.
Over a 20-year period, which is usual depreciation of the factories, you start reorganizing the ecosystem towards cheaper energy, cheaper production by creating these sort of ecosystems.
Right. And in Denmark, the biggest change in the energy mix has been towards wind and a little, well, some efficiency too, but especially wind. And wind is part of this cluster here along with the solar. So why don't we, and it was already suggested, let's promote the renewables along with the nuclear. So
Sir, actually my point was to the ecosystem. So how do we incentivize industries to make the switch? Driving them
away from fossil fuels? Okay, so that would be over here, electrification and efficiency. We can go there in a minute. But let's see what happens if we heavily incentivize renewables. So a package of subsidies and tax credits. We know exactly how to do this. It's part of the IRA in this country. So we're at 3.14, and now we're at 3.06. So almost another tenth. So that's more progress, right? Now you'll also notice when you do that, you are reducing the amount of nuclear you get, right? Okay, well, we're making some progress, but we're a long way from where we need to be. Ma'am, right here.
I have a question about the model. With the renewable section, you have solar, wind, and I'm assuming hydro.
Hydro and geothermal, and yeah, go ahead.
Do you separate them out to ever have hydro separate, or why in the model do you have hydro?
We're just plotting them together because they're all producing zero carbon electricity. But yeah, we do track them all separately because they have different costs, they have different supply curves, they have rates of technological progress that differ and so forth. But yes, they are treated separately. So
Then my other question would be, could we do something to reduce the amount of methane produced?
okay, great. Methane is very powerful greenhouse gas, and we haven't really touched it here, maybe a little bit, barely down. So what if we implement a set of policies and programs that could reduce the emissions of methane across the board, from the energy industry, from other industries, from agriculture. So this is a high leverage action, right? Now, I'm not going to go all the way to 100%. You can try that on your own. 80% would be pretty aggressive. Emissions don't go to zero, but they go down a lot, and that was worth 0.3 of a degree. That's a big deal. Why is that true? Anybody? It's 80 times more powerful than CO2, molecule for molecule, over 20 years, and it doesn't stay in the atmosphere as long as CO2 does. So if you can stop the emissions of methane, you can make a big difference in the short run. Yeah, go ahead.
One more thing is, I want you to know that I'm a high school teacher that uses this model in my classroom.
Good for you. Fantastic, fantastic. And how do your kids like it?
They love it.
Yeah.
They get to play and choose.
So that's one of the things that's most gratifying to me, is to see how many people from all over the world, 178 countries, from middle school and high school kids to senators and Congress people, and don't get cynical and say, well, that's about the same thing, because it's not, okay? It's not. All right, 2.8, we're making a lot of progress. Oh, can I call on the lobbyist here? All right, Bob, go.
Well, no, I'm interested in the energy efficiency story.
All right.
Probably for buildings and industry.
Okay.
You could do transport too, but I'm interested in what that would
Let's start with buildings and industry. Now, they're separate in the model, just like hydro and wind and solar are separate, but one slider is going to accelerate energy efficiency improvements in both the built environment, so housing, commercial space, hotels like this, and industrial processes.
How about data centers? Would that be
Data centers, yes.
Okay, good.
All right, so we're at 2.83. Let's go for it. I won't pull it all the way. That made a big difference. That's another 0.2. Now, why? Well, one of the big reasons is, first of all, there's a lot of waste still in all of these processes. And efficiency, unlike building new nuclear plants and some of the other actions here like CCS, it can be done very, very quickly. Everybody here, I think, understands the time value of money, right? You would strictly prefer me to give you $1 million today than $1 million in 2030, right? In exactly the same way, it's much better to take a ton of carbon out today than to take that ton out in 20, 30, 50 or later. Why? Because once you've put that CO2 in the atmosphere, it warms the planet every day for over 100 years. So efficiency can be done very quickly, and that gives it a lot of its impact. As long as we're doing efficiency, why don't we also do it for transportation? Is that okay?
Yep. Yes.
Transportation isn't as big of a contributor overall to emissions as the built environment and industry, but let's do that. There's another 1/10. We're at 2.5. Fantastic. So yeah, we do have energy storage in the model. You need it when you have a lot more renewables than we have today. And of course, it's being deployed now with batteries and compressed air and pumped hydro, and there's lots of ways to do this. I am going to disagree. Perhaps you were being ironic. Coal is the dirtiest fuel. It is the most CO2 per kilowatt hour of any of the fuels. So just wanted to get that on the record. So coal is down quite a bit, but there's still coal in the mix here. It's abundant around the world, and it's heavily subsidized in a lot of countries. So what else do you all want to do to reduce the amount of coal we got going? Yeah, right? Put a price on carbon. And you actually mentioned this. All the oil companies are on the record supporting that. Do you have an idea of how much of a price on carbon you'd like to impose? Okay. So most people have no idea how many dollars per ton of CO2. What would that mean? 50. All right, we can try that. The global average is about 5 right now. Let's try 50. What, you want 500? No. Oh, okay. 50.
50 is 10.
There we go. Let me do that again. We were at 2.4, and now that's a whole another 0.2 of a degree, even after all the other actions. That's really very important. By the way, let's just take a really quick look here. If I start with the base case, and we've done nothing else, and we go with $50 a ton, 3.3 down to 3.1. And if you have an even higher carbon price, well, let's go back to our main scenario. Yep, let's try 120. 120 is not that crazy. The European trading system, which is a cap and trade system in existence for many years now, has recently been trading since the war in Ukraine started in the 60 to 90 euros per ton. So that's not that unreasonable. Let's try 120.
120 would be about $1 per gallon
About
of gas.
About $1 a gallon on gasoline in this country. So now there is a really, so 2.1, this is a high leverage action, but there's a really big problem, and it speaks directly to what we just heard about equity and racism and justice. This is a high leverage action. It makes a big difference. Why does it make a big difference? Well, it affects all the fuels, and it encourages even more efficiency, even after we've pulled the efficiency lever here. But it would be regressive. Low-income people would have an even higher energy burden. So we need to solve that problem. How can we solve that problem?
Give it back to the people.
Oh, Bill, come on. All right.
Oh, come on.
Bill spilled the beans here. Right, you give it back to the people. So Bill,
Carbon dividends.
yep, that's what it's called. It's called the carbon dividend. So the way, well, do we have any folks from Canada here today? No Canadians? Our neighbors from the north?
They can't sell that.
So Canada actually has this policy right now. They call it a carbon rebate. Every citizen of Canada gets a check 4 times a year, which is their share of Canada's carbon price revenue. Right now, their carbon price is about $50 a ton, and it's scheduled to rise. Now, they have a new government. We'll see what happens. But it's scheduled to rise well over 100 in the next years. Every dollar of that, every loonie goes back to the people. Think about what that means. It means if you're a low-income person, if you're black or brown, if you live in a community that's economically disadvantaged, you get a pretty big check relative to your income. And by the way, folks in those communities don't have big carbon footprints because they're economically disadvantaged. They're not driving a lot. Many of them are on the bus or walking because they can't afford a car. They don't have 2 houses. They don't have a big house. They don't fly a lot because they don't have the income to do so. So in many cases, those folks are going to get more back in their share of that carbon revenue than it costs them in higher energy prices. Whereas affluent, privileged people, like pretty much everybody in this room, we can afford it. And everybody still has the incentive to switch away from the fossils and towards the more efficient sources of energy. So coal, being the most carbon intensive, pretty much goes away. That leaves us with a lot of oil, some gas, a lot of renewables, and we've heavily incentivized nuclear. It's still there. 2.1. Now we ain't done. We got well below. Oh, sorry, go ahead.
Electrified transportation.
All right, let's electrify transportation. So, well, first, let's see what's happening there. In our base case, we do have electrification happening because we have electric vehicles now, and that can spread further. It's slightly accelerated by the actions you've already suggested to me, but we could do more. So why don't we do more? Now, the market share of electric vehicles goes way up, much faster. Did it make much difference? Well, let's see where we were exactly. We were at 2.12, and now we're at 2.07. So it mattered, but it's not a game changer by itself. Any thoughts as to why? And by the way, I have 2 electric cars. I don't drive much because I bike, and they're great. They're way better. Just, you know, the acceleration, the performance, the quiet, they're just better. But why doesn't it make more difference? Yeah, go ahead. So there is a life cycle impact. It takes more energy to build an electric car than a conventional car. We account for that. So that's a bit of the story. Anything? Yeah, go ahead. Well, so we do all these other actions. Well, so here, let's take a look. Let's go back to the base case here. I'll reset to the base case. And if we electrify in the base case, it makes almost no difference at all. And that's because in the base case, look what happens. You get more coal. Now, in this country, if you purchase an electric car, you're helping. On net, even accounting for where the electricity to charge the battery comes from, you're reducing total emissions. But in China, in India, no, because most of the electricity is coming from coal. Now, you are reducing tailpipe emissions. That's good if you're breathing the air in Shanghai or Beijing. But you've got more coal plant emissions, and that's not good if you're breathing the air in Shanghai and Beijing. Yeah, Jennifer.
What about adding a couple of factors here? One would be equity, and one, frankly, would recognize differences in different countries. And, you know, that is our issue. You know, California has a very robust cap and trade program, and all of the money gets wasted.
Well, it's not rebated to the public.
No, it's wasted.
Okay.
Talk about actual
So,
GHG reductions on a per
I am with you.
dollar basis.
I am with you. Equity and social justice here is critical. Well, so, okay. Let's talk about political feasibility in a minute. And by the way, since your all comments were so terrific and we ran over the schedule, we're going to go, and I have permission from Doozy here, we're going to go to 3:15. I hope that's okay, right? So, the way, okay, so back to equity and social justice here.
And political feasibility.
So let me make a comment about political feasibility first. What's been happening in this country and many other countries is people have been spending an awful lot of their political capital, lobbying, philanthropic effort on solutions that simply can't make a big difference in time. That's a terrible waste. And we already saw some of them. You know, and they span the political spectrum, right? CCS, heavily promoted by fossil industry. Doesn't make a huge difference because of the factors we talked about. It's expensive. It takes a long time to build them. There's a lot of public resistance to them, as you talked about, and that slows things down. And then you've got this problem that you're not cutting emissions quickly enough to matter. Same with nuclear. Takes a long time, very expensive, and cannibalizes your other low carbon sources. So those are low leverage solutions. Other low leverage solutions, well, planting a lot of trees is great. Personally, I like to be in the forest as much as I possibly can. But it takes so long for those trees to grow. I don't know, have any of you ever been part of a tree planting effort? I have. What? How big are those trees you're planting? They're this big. They have no leaves yet. It takes decades, and depending on the species and where you plant them, a century for them to get big enough to be really sucking a lot of carbon out of the air, if they survive and they don't burn or succumb to pests and disease, all of those risks, or extreme weather, all of those risks becoming worse with climate change. So plant trees for sure, but don't fool yourself that that's a solution. Take a look at where we're at. There's no way to get where we want to go unless we're reducing the CO2 from the fossils and the methane, as well as the nature-based emissions. Yes, sir, go ahead.
You want to do some work on the technological end,
Technological carbon dioxide removal, great. So we have direct air capture and we have enhanced mineralization, for example, here. Now these are very expensive right now. A couple pilot plants working around the world, but they're really expensive and they're operating at the 1,000 tons per year. We need to be operating at the billion ton per year scale. But let's try it out, 2.07, and we'll go, let's say about here. and 2.01. We're almost at 2. So that can help if those technologies prove to be feasible. Now, I'm from MIT. I think there's a lot of reason to be optimistic about innovation. But again, long time delays. All right, what else, folks? Some new voices? Can we get some new voices? Are you holding up your hand, sir?
Yeah.
All right, Bill.
Ocean, is there a way to enhance the absorption of carbon by oceans?
Marine carbon dioxide removal. That would be in this category. I'll pull the lever some more. How's that? Yeah, it's technological. There's many proposals out there. Kelp forests, ocean seeding with iron, many, removal of CO2 and then sequestering it on shore. Many proposals. None of them are happening at scale, and there's a lot of public opposition. So we get back to the politics story. Oh, way in the back. Go ahead. What else should we be doing here?
I can't see from back here, but do you have any of the geoengineering schemes there?
We do not have geoengineering. So in particular, solar radiation management, which is cloud brightening or injecting sulfate aerosols into the stratosphere. And I'll tell you why we don't have it in the model. We've been asked over and over again to do this. And we can model the direct effects. Solar radiation management with sulfate aerosols or cloud brightening, it's pretty cheap. Any country could actually launch on their own a program to put a huge amount of sulfate into the stratosphere today, and it's pretty cheap. And what it does is the sky won't be blue, it'll be kind of a dull white, and those particles reflect some of the sunlight back into space. It will cool the Earth. So we can model that. What no scientist can credibly model yet are the potential unintended harms, the Rumsfeldian unknown unknowns. And a lot of those, there's a lot of discussion of what they might be, and they're potentially very harmful. I'll give you a really quick scenario. Let's say China launches an aerosol injection policy. Pretty cheap. They could run it from Xinjiang province. And it'll cool the planet a little bit. But then, a couple of years later, maybe the monsoon in South Asia fails. There's some modeling that suggests that's a possible consequence of SRM. But it wouldn't matter if it's caused by the program or it just happens anyway. So when the monsoon fails at scale, people are starving in India and Pakistan and South Asia. India demands that China cease and desist. China says no. Now you have a geopolitical confrontation between two nuclear powers. You can't model that. You can't model what happens to crop yields reliably around the world. So my personal view is it's unethical to put that into our model, because what will happen is people will pull the slider and say, look, it cooled the planet, problem solved. And the problem is not solved, including it will do nothing to slow down ocean acidification. All that carbon we're putting in the atmosphere, about half of it ends up in the ocean, where it lowers the pH, makes the ocean more acidic, which is already harming corals and will continue to harm any creature that forms a shell. And that's the base of the food webs in the ocean that feeds hundreds of millions of people around the planet. SRM doesn't do anything to stop that. So, not in the model right now.
I couldn't agree with you more, but a lot of people, it's very powerful people who are considering that. And even didn't Hansen at all do the study looking at the reduction in emissions from ships transiting the seas and all?
Yeah, so we do have that. So I think what you're referring to, maybe many of you know, but there's a lot of sulfate that's produced now as pollution from burning dirty fuels. In maritime shipping, high sulfur, cheap bunker oils produced a lot of this, but also just burning the coal everywhere and so forth. So the IMO, the International Maritime Organization, essentially banned high sulfur fuels a couple of years ago. And because all that sulfate and PM 2.5 that I showed you earlier is killing so many people prematurely around the world, even China, India, and other countries have been trying to reduce it, and it's going down. Well, that sulfate is a cooling agent. So it's been masking a lot of the warming. And as we reduce that horrible pollution, we're saving lives, labor productivity goes up, children do better in schools and have better life outcomes, but the planet starts to warm up more quickly. That's happening right now. It's in the model. Way in the back, what else can we do to get well below 2 degrees? So you mean like ground source heat pumps, geothermal? Oh, I see. Deep geothermal, high temp. Yeah, that's part of the renewable package here. But there's an even, so you can do it where it's hot, right? Where there's, like in Yellowstone, like in Iceland. But you can't do it everywhere. And so an even more attractive, economically feasible option is what we call ground source heat pumps. So maybe some of you already have this in your neighborhood, in your homes. So that's not deep wells, but just using the heat in the earth, which is around 40 degrees Fahrenheit all the time, to heat in the winter and cool in the summer. This is a very promising technology. It's part of the energy efficiency story here. I'll pull that a little more. So there's 1.9. So
Now we've broken through 2 degrees.
yeah, we're below 2 degrees here, right? So yeah. Now, we have a few minutes left. We could do more. I think we could get lower. But what I'd like to do is transition to a discussion with you all. And to kick that off, first of all, notice that I didn't tell you what to try. Everything we tried here came from you all. And you've done it. You've gotten us below 2 degrees. Is that going to matter to us? Well, first of all, let's take a look at what some of these harms are. Well, here's the temperature pathway. We stay well below 2, and we really slow down. The slower that warming happens, the more time we've got to adapt and to help the people who are going to be hurt the most. Coming back to Jennifer's point, the people who are going to suffer, who are right now today and will in the future suffer the most from climate change, are the people who have contributed the least to the problem because they are the low-income poor of the world in every country, not just the poor. You know, the average carbon footprint of somebody in Mali, I think you said you work there, is negligible compared to the average American. But likewise, even in this country, the average carbon footprint of somebody from a poor neighborhood in Mississippi or Mattapan, a poor neighborhood in Boston, much lower than average. They're going to suffer the most, they've contributed the least, and they have the fewest resources to adapt. What we've got here is a world in which there's a lot more time to adapt, and with your carbon price, you're generating trillions of dollars a year that's rebated to those folks to help them deal with those issues. What else is going on? Well, have we made a difference on some of these other harms? Well, let's take a look at air pollution. PM 2.5 goes down a lot, and it goes down quickly. This is a lot of lives saved. This is a big bump in labor productivity. This is kids doing better in school, kids having better life outcomes. That's a big deal. What other benefits do we have? Oh gosh, let's see. Oh, I showed you crop yield before, right? Where's crop yield? Here it is. Crop yields are still expected to fall. Listen, 1.9 is warmer than we are now. One of the sobering things about this issue is we've waited so long to take it seriously that no matter what we do, it's going to get warmer. And that'll bring more harm. But this is a much safer world than where we were headed without. So this gives us more time for adaptation as well. What else? Oh gosh. Wildfire. You can take a quick look at that. Look at the US. That's 2100 in the current scenario. In the baseline, it's much worse. So there's reduction in harm and risk everywhere. Now, what does it mean for the economy? I'm always asked, what is this all going to cost? So here's your base case again. Let's take a look at this graph right there. That is real economic output per person. The dashed line is what it would do, economic growth, if climate had no future impact on the economy at all, which we know is wrong. And the solid line is the estimate from one widely regarded peer-reviewed study of how much economic loss there would be. Personally, I believe this is dramatically over-optimistic. GDP is likely to fall more. But we'll stick with the science here. And you might say, well, look, the economy is still growing. What's the big deal? You see that little dip right there? That's the economic harm from COVID. We all lived through it. None of us want to do that again. Compared to what's coming from climate change, COVID is an insignificant blip. So, what happens in our scenario, your scenario? Let's take a look at the economy. Economic growth is much accelerated. People focus too much on the short-run costs of all the levers that you've pulled here. And there are short-run costs. And there's not nearly enough attention paid to the benefits of a world that's not experiencing severe and irreversible consequences. Ability to adapt. So let me pause here and see what you all think. And the political feasibility question is one. The equity question is another. And there's a question for you from us. How do you think this tool might be helpful for you, your organization, whether it's a company, an investment group, schools, faith groups, whatever it might be? What do you got? Thoughts? Yes?
Can I ask you a question first?
Sure.
How many trained ambassadors do you have using it now?
So we have a program that we call the Climate Ambassadors, and let me update the page. 888 people from 90 countries around the world, and you can see some of them here. They are from every conceivable race and ethnicity and religious group and socioeconomic status. Some of them are senior executives in major corporations. Some of them are community activists at the village level in Africa. And everybody here can go through our free training and learn how to do this effectively with the communities you're part of, and then get it out there.
Okay, now I have a question.
Okay.
Which is, when people participate, does it discourage them from taking individual action and collective action? Or does it encourage them to take all sorts of different kinds of action to be additive like what we did?
What a fantastic question. So let me summarize it. Does it work? Do people get discouraged by doing this, or does it motivate them to take action? So we have been studying this well. Let me ask the group. How many of you are discouraged more than you were when you came in? It's okay to say yes. One. Okay, how many of you are a little more encouraged than before you came in? You got to vote. You can't just say, well, I was on my phone the whole time. I it was. Hopefully you weren't. Okay, so dramatically large majority for a little more hopeful here. We have studied this scientifically. There's now 4 peer-reviewed papers that are publicly available that ask exactly this question. And the answer is, with thousands of people in the different samples from all over the world, the answer is people learn more about climate and energy, but even more important, they come away more emotionally engaged. And some of that is fear, because we're headed on a path to catastrophe. But they also come away with what we call hope. Now, hope is not the idea that somebody else is going to solve this problem for us. It's exactly what you alluded to. The technical term would be agency. It's the belief that what I do as a participant in this, what we do collectively, can matter. So we always call upon people to take action in 3 ways. Personally, change the way you live, right? Bike to work, put solar on your house, get an electric vehicle. Professionally, Start transforming your organization, whether it's a for-profit or the oil industry or a nonprofit or a faith group. And I'm going to call it politically, but I don't necessarily mean partisan. I mean taking action as a citizen, talking to your elected representatives, meeting with them at every level of government so that they know people out there want to make a difference on these issues. That works. That's where we need to go. We're constantly updating the model because the science is changing, the climate is changing, the economics are changing, the global economy is changing. If NOAA's ability to track what's happening with the climate, if our ability to look down from space at Earth and see what's happening, if those are compromised, we're going to be flying blind. And, just imagine driving your car on the freeway out here with your foot to the floor, but a blindfold over your head. You're not going to last very long. Doesn't change the reality to pretend it ain't happening. So that would be a leverage point going forward. All right, Bill, I'm going to hand it over to you to make whatever final comments you want.
Thank you, John. Thank you, Dr. Sterman. And